We all know that last year on the 25th of December, NASA launched a $10 billion James Webb Space Telescope. We made a detailed video about the Webb telescope. You should watch that video to know every single detail of this telescope. The telescope is deployed at Lagrange Point 2, also known as L2. A Lagrange point is a gravitationally stable location in space. L2 is a spot in space near Earth that lies opposite from the Sun. Deploying the Webb at L2 will allow the telescope to stay in line with Earth as it orbits the Sun. It took 30 days for the James Webb Space Telescope to travel 1.5 million kilometers and reach L2. You can see actual footage of the telescope when it was leaving the Ariane 5 rocket. The Webb slowly drifts away from its rocket stage and unfurls its solar panels. The Webb was fully deployed at L2 on January 8th of 2022. After reaching the L2, the telescope took a selfie with a camera inside NIR cam. The camera is designed to be used mainly for engineering and alignment purposes. In the selfie, you can see one of the mirror segments is shining brighter than the others. This is because it is the only segment at the time successfully aligned and pointing at a star. The rest of the mirror segments were successfully aligned one by one. After the deployment, the first step for the scientists was to align its 18 mirrors. When these 18 mirrors are combined, it makes a whole big aperture of a telescope. Almost a month later, after the first phase alignment process completed, the Webb was pointed at a bright isolated star in the constellation Ursa Major, known as HG 84406. This star was chosen specifically because it is easily identifiable and not crowded by other stars of similar brightness. This helps to reduce background light and the confusion. In this image, all you see are the 18 scattered dots. Each dot is captured by each individual mirror of the Webb. You can see the name of each mirror in this photo. After the first phase was over, during the second phase, scientists didn't know which dot image taken by which mirror, so eventually they figured it out. They arranged the images as shown as taken by each mirror of the Webb in a honeycomb pattern. When these 18 individual images are stacked over each other, it gives a single image of a star as shown in this picture. In the fourth phase of alignment, the scientists work specifically on the sharpness of the images taken by the 18 mirrors of the Webb. As there are 4 main instruments on the Webb, all the 4 instruments are designed to absorb infrared light. Each instrument has a different role. The near-infrared camera is the main imaging system of the telescope. It can look back in the time during the earliest formation of the galaxy. The near-infrared spectrograph will collect the spectral information of an object such as their composition, velocity, and mass. The mid-infrared instrument will look at wavelengths of light, which are a little longer than other instruments cannot observe. This is the coldest instrument on the Webb. It will help find planets around distant stars. The near-infrared imager and the slit-less spectrograph will be finding ancient light in the universe and the information about the distant planets and stars. During the sharpness check, Webb was pointed at the part of the Large Magellanic Cloud, a small satellite galaxy of the Milky Way. Of the main 4 instruments, each instrument is capable of taking images at different wavelengths of light. On April 28th, the Webb was fully aligned with all its capacities. On May 9th, scientists released other comparison images of the Webb. As you saw in this previous sharpness check, each of the 4 instruments has taken an image. One of the instruments is MIRI, or Mid-Infrared Instrument. Scientists compared the image taken by the MIRI instrument with a past image of the same target taken with NASA's Spitzer Space Telescope. When you see both these images, the Webb image is much clearer and shows the interstellar gas in between the stars. It is not only the image of the star, but the stars and galaxies behind them with improved clarity, enabling even more discoveries. Scientists recently have taken the picture of a black hole in the center of our galaxy with the help of the Event Horizon Telescope. By the way, if you don't know how that picture was taken, please watch this video on our channel. One of the questions scientists still are finding an answer to is how galaxies have these massive black holes at the center. The Webb telescope will help to find these answers. The Webb will study and search for the first black holes in the early universe. The black holes which we find at the center of every galaxy probably grew from these early-stage black holes from the early universe. There are a few images taken by the James Webb Space Telescope. One thing to notice here is that all the images taken are not for study purposes, but for setting up and aligning the telescope. The Webb has shown its capability in these first demo images itself. You can imagine how exciting and detailed images of the universe this telescope will show us. We will definitely cover all the images taken by this masterpiece of a telescope in the future. If you like this video, then give it a like and subscribe to the channel for more such content. Also, visit our website to learn more about astronomy and stargazing. You can discuss your ideas and ask questions on the site's forum as well.